Welcome to Ask and Learn.
This question shows the carbon-nitrogen cycle that occurs in the sun, where we have hydrogen, protium, just one proton, involved in several different reactions that results in the net formation of helium. So let's rewrite the mechanism. First reaction is a proton reacting with carbon-12 to produce nitrogen-13, then nitrogen-13 falling apart into carbon-13, emitting a positron, then a proton reacting with carbon-13 that was created in the previous reaction to produce nitrogen-14, and then another proton reacting with nitrogen-14 to produce oxygen-15, oxygen-15 decomposing into nitrogen-15 and a positron, and then another proton reacting with nitrogen-15 to produce carbon-12, and finally helium as our product. If we sum up all of these reactions, we get the net reaction of 4 protons producing 1 helium nucleus, and in the process emitting 2 positrons. For part A, it asks us to identify the catalyst. The catalyst is going to be something that was consumed and then later recreated in the mechanism. If we look closely, we see that carbon-12 was consumed in the first step and later recreated in the last step. This would then be our catalyst. For the intermediates are created and later consumed. So we have nitrogen-13 being created and then consumed in the subsequent step, carbon-13 being created and consumed in the subsequent step, nitrogen-14 being created and then consumed in the subsequent step, oxygen-15 being created and consumed in the subsequent step, and then nitrogen-15 being created and consumed in the subsequent step. So all of these are intermediates. Then for part C, it wants us to calculate the energy that is released per mole of hydrogen nuclei that's involved in the overall reaction. Then they give us the masses associated with just the proton and the helium nucleus. First thing that we need to do is calculate the mass defect. The mass defect is going to be the masses of the products. There are 2 positrons. Positron should have the same mass as an electron. So 5.486 times 10 to the negative 4 grams per mole. There are 2 of them that are created in the overall reaction, plus the mass of the helium nucleus, which was provided to us as 4.00260 atomic mass units, the U. But we can also use that exact same number for grams of a mole of helium nuclei. So we'll assume here this is grams per mole, just as we did here. And then we'll subtract off the mass of the reactants, 4 times the mass of a mole of a proton, 1.00782. That gives us a mass defect, a loss which will be represented as negative, of negative 2.7583 times 10 to the negative 2 grams. Then, to calculate the energy associated with this mass defect, we need to use the Einstein equation, E equals mc squared. The mass we just calculated up here, however, needs to be expressed not in grams, but rather in kilograms in order to have this equation be appropriate. So E then is going to be equal to negative 2.7583 times 10 to the negative 5 kilograms. And then we multiply that by the speed of light squared, 2.9979 times 10 to the 8 meters per second, and we square it. This will then give us a total amount of energy for this reaction as written as negative 2.4790 times 10 to the 12 joules. However, this is for the reaction as written, and as written, 4 moles of protons are involved. So this is the joules per 4 moles of protons. It wants to know the energy that is released per single mole of protons. So we simply need to divide 4 into this value to get our overall value of negative 6.197 times 10 to the 11 joules per mole of protons that react in the overall reaction.